think we can start. Hello, everyone, and welcome to our webinar series, Rutronik Connects. The first week was all about Wi-Fi. 2 weeks ago, we had sessions about cellular and GNSS, and this week is all about ultra-wideband, LoRa, and some other technologies. Today, I want to welcome Jens Kattenbusch from our strong partner KYOCERA AVX with the topic High Performance Ultra-Wideband and LPWAN Antenna Systems. Here you can see us both. My name is Tobias Lusch, and as I said, I want to welcome Jens Kattenbusch from KYOCERA AVX. The practicalities, the duration of the webinar will be 1 hour. Questions are, of course, welcome. You can type them in the Q&A on the right sidebar. We will answer them at the end of the session. If you have questions afterwards, you can, of course, contact us anytime. I will tell you later. The presentation and the slides will be recorded, and you will receive it afterwards, and of course also our presentations. So, hello Jens, you can start.
Thank you, Tobias. So I will just start sharing as well. And I hope you can see my screen. So yeah, thank you, Tobias, for the warm welcome. And hello everyone for joining this webinar today. Today we want to talk about ultra-wideband, low-power wide area network antenna systems. And my name is Jens Kattenbusch. I'm the technical sales manager for KYOCERA AVX, located in Germany, taking care of Central and Eastern Europe. So some general facts about KYOCERA AVX. We are a probably well-known brand, but we are also working with antennas for a couple of years already. The main antenna business came from custom designs. That's why we are very, very strong in our own designs. We have a lot of own patents that we developed for our customers or for ourselves to have our own solutions and not just produce any antenna for everyone. We have a lot of measurement chambers, so in total 25, more than 25 measurement chambers globally. I will show the locations later on, and doing active and passive antenna systems as well as measurement systems. So we also develop our own measurement chambers for special use cases, especially ultra wideband. We have some nice things going on here, and generally a broad portfolio and custom and standard antennas. In terms of applications, we are basically in most of the key markets in Europe, but also worldwide. One of our biggest businesses is, for example, gateways and routers in Asia, or smartphones as well, automotive, industrial, IoT, medical, and tracking. Here you can see our main locations in terms of design centers as well as manufacturing sites. So we do not only produce in China, we also have our plants in Korea and Vietnam, depending on the product series. But we can also shift production of different products to different locations, just in case it is needed for specific use cases. In terms of design centers, we are also based, of course, in the Asian countries. For us in Europe, the main headquarters is Nice in France. Here we have our biggest automotive chamber, and most of our product managers and R&D guys are located here or in San Diego. So we can really support customers worldwide. So each design center is doing some custom parts, and each design center is doing local support for projects. A little bit more specific for this topic today. Some applications and some products we provide for industrial gateways, for example, wearables, satellite communication, automotive, smart homes, and metering and lighting. So here we have, for example, our ISM LoRa 868 950 megahertz, but also NB-IoT DECT NR+, which I would also count as a partly low power wide area network technology because the range is quite high, as well as, of course, also Bluetooth and other technologies. We have presented them already with Rutronik as well in other webinars, or there will be another webinar for Bluetooth if you're interested specifically for this topic. So yeah, in these markets, also ultra wideband is coming more and more. For example, wearables in smart homes, in metering. Sometimes ultra wideband is also used, also in automotive. And why ultra wideband makes sense in some applications, I just wanted to break down here briefly, since we do not provide modules and the hardware and software behind these big benefits here, like data rates, latency, bandwidth, the lower energy consumption, high security, and of course high precision tracking. I would like to focus more on the antenna topics. I think most of these inputs you can find on the module suppliers or with Rutronik. Using these key features, the antenna plays, of course, an important role to optimize each of these topics here. If the antenna is matched better or worse, the difference between the energy consumption and the data rates can be drastic, and of course also the precision tracking can be differing huge between well-matched antenna and not so well-matched antennas. So in Europe, USA, and some Asian countries, mostly we focus on these two bands or channels, 5 and 9, using these center frequencies here, 6.5 roughly, and 8 gigahertz, having a bandwidth of around 500 megahertz each. So that's where we are focusing on, but all our antennas are covering most of the ultra wideband range between 3.5 and 10.6 gigahertz. The next technology we want to talk about in this webinar is low power wide area network technologies. So I split it up between cellular protocols and ISM-based protocols. Also here, each of these technologies has different advantages, like global coverage for cellular, having a broader frequency range, at least compared to ISM frequency bands. We have lower but also middle-sized data packages. It's not high data throughput, so that can be, of course, combined with ultra-wideband having a quite high data rate due to the high bandwidth of ultra-wideband. And we usually have quite well reliability when the area is covered with base stations. In terms of ISM, usually that's a local system that everyone can build up themselves, or there are private and public networks that can be used to cover certain areas. The frequency band is quite narrow and the data rates are quite low, so it's low data packages possible. And it usually is quite reliable, depending also on the protocol you're using. So here, just to name a few, there's of course LoRa, there's MyOT, and a lot more that you can use besides developing a own protocol, which is also a benefit, of course, of ISM. And I just wanted to take a look at different scenarios to to give some ideas on how to use it. So one is a tracking application. So we have a cellular part and an ultra-wideband part. I just took a cat, for example, because it's indoor and outdoor. So usually there's also some other outdoor tracking technology like GPS, for example. But also with ultra-wideband, it's of course possible to have a device that's usable outdoors, and the cat can be maybe in the city somewhere, can be maybe in the landscape, or if you're lucky, it's just under the sofa, and you can track it with ultra-wideband even within your house. So that's why ultra-wideband makes also sense, for example, for some of these applications. This may be a nice use case, but of course there's much more that can be tracked with ultra-wideband. And another example is, for example, in the logistics, and we have quite a few use cases already here. So let's say the robot needs to be tracked in the warehouse, but maybe he's also outside, so it's a big plant. Maybe not everything is covered by the Wi-Fi network, or they just want to save some costs on Wi-Fi access points, so they just have a ISM network, a local network on the plant. So here it can be combined ultra-wideband and ISM in this case. Also having the advantage that the ISM network, due to the lower data rate, due to the lower frequency, also penetrates the house quite well compared to Wi-Fi, for example. And of course, with ultra-wideband, the robot can be tracked no matter where it is. And of course, precisely with centimeter accuracy. In terms of products, we have a lot of different kinds of products available for cellular mostly. All of them can be used for ISM frequencies as well, but we focus them for cellular because it covers the 868, 915 megahertz as well. And we have different versions of our SMD type antennas, for example, having a smaller one and a bigger one. Of course, they both have different PCB size requirements, and both of them have mirrored versions available, so you can either use it on the left side, on the right side of the PCB, or on the top and the bottom, depending on the device, or if you need multiple ones. And for most of the antennas, we also have different tuning technologies or tuning options. So the P822-601, for example, can be tuned in the lower frequency range, for example, also specifically for 868, 915 megahertz, but also the NB-IoT LDM network, and also in the upper frequency range. And additionally, there is one pin for the matching network, so just to make sure the frequency is in the right area. Other types of antennas that we have for these technologies is one of our vertical PCB board that can be just sticked into a PCB, and our off-board antennas, which are also quite popular. And here we also have nice options to optimize and to customize the antennas. The trend is going towards less cable and, for example, spring contacts instead of cables, and that we can do custom for you. Also here, these antennas are available for 5G, 4G, and ISM frequencies 868 and 915 megahertz. Some of these are also on board, so they are using the ground plane of the PCB board, and some of them are off board, so they are ground plane independent, not needing the ground plane, the PCB board, as much as the ground plane dependent antennas. In terms of external antennas, we split our portfolio into indoor and outdoor. outdoor antennas usually have IP rating, so IP67 typically. Indoor antennas, they don't have IP rating, but there are also a lot of different options available. So it's still a nice product to have. And especially here, it's very, very easy to use, especially for cellular or some LoRa applications. Specifically for 868 and 950 megahertz, we have a few antennas dedicated to these frequencies. On the left side, you can see our SMD type antennas. So we have different sizes. This one is 22 by 3.2 millimeters. This one is 6 by 2, and this one is the smallest one, 1 by 0.55 millimeters in size. Of course, they're always strongly ground plane dependent. So the PCB size should be at least 10 centimeters, 100 millimeters in length, just to make sure to cover enough range. But I have a slide later on showing a little bit more detailed the effect on cutting the PCB size. All of these are, of course, SMT solderable, so quite easy to implement, and usually, if it's possible, the best choice we would like to provide if there is space on the PCB or the PCB is big enough. And also here, some of them can be used also for other technologies. For example, the top one for Bluetooth and Wi-Fi. In this case, the layout is different. So we have different application nodes or different layouts on the application node showing the layout for 2.45 gigahertz compared to the layout to ISM frequencies 868 and 915. We also have a directional antenna, which is a right-hand polarized antenna, patch antenna. So it's a quite big one, but if you need to achieve certain ranges, to have a directional pattern, a few kilometers are definitely possible. I've seen some tests with LoRa for more than 30 kilometers, and then this might be a very nice option. We have either one version for 868 or another one for 915 megahertz because they're so narrow in bandwidth to optimize the range and the throughput. Another very new option is our FPC cabled antenna. So it's a flexible PCB type antenna. So you can actually bend it according to your housing, for example. You can have different cable options and different connector options. And it's quite small. That means it's also ground plane dependent. So always depending on the PCB size. We also have different external antennas. Also here, one indoor antenna and an outdoor antenna, IP67 rated. That one's quite big and has a very, very nice gain. So that's also one of our most sold antennas for 868 megahertz or 915 megahertz. Another very nice addition to our antennas is our self-developed active band switch, especially for cellular and smaller boards. We always recommend to use it. It's a very, very tiny 1.1 by 1.5 millimeters chip. It's a SP4T switching chip, so you have different inputs for inputs that you can tune individually. So in this case, for example, 760, 840, 900 megahertz and 720 megahertz, which are especially optimized by reducing the return losses internally. And we can gain up to almost 40% in average, we say 10-20% of efficiency by having the switching chip. The chip itself can be used between 300 megahertz to 3 gigahertz, so it's quite a nice range. So can be also used for Bluetooth, for example, or other technologies. Coming to our ultra-wideband antennas, also here we have already quite a few options. Starting here from small to bigger one, our super small chip antenna, it's the same size as the super small ISM antenna, so also only 1 millimeter in size. It's the smallest antenna I know on the market, still having a quite high tolerance, and is made for ultra wideband, but we have a similar antenna also for Bluetooth and Wi-Fi. The next one is our 1,013,12. It's a little bit bigger in size, double the size than the smallest. Is still very, very cost efficient. The difference between these two is also the ground clearance area that's needed on the PCB. So not always the smaller antenna is the better choice just because it's smaller. The performance in both is quite good, but it really depends on the layout of the device, which antenna to choose. Another technology or type of product we offer is a metal stamped antenna. This is originated from our Wi-Fi portfolio, and we were able to adapt it to ultra wideband frequencies. And it's also quite cost efficient, having the advantage that it's a little bit less noise affected compared to the chip antennas, or what we often see is some trace antenna designs where customers just use a PCB trace to design the antennas. These are usually the cheapest options to do, but they are quite attracted to noise and any kind of interruptions here. So one customer is using, or he used in the past some trace antennas, but it was a device that was worn on a person's body, and the noise coming from different things on the person, like a smartphone or keychain or whatever, was so strong that he decided to take he preferred the metal stamp antenna, but in the end it was the chip antenna due to the design advantages. And our latest newest addition is our tulip antenna. That's a LDS 3-dimensional design. It's a plastic carrier which is metallized by laser structuring. It's also SMD solderable, so it's quite easy to use. And this one is placed directly in the center of the PCB here, as you can see, and it's polarized perpendicular to the PCB in a linear way. And here you can also see the advantages of having the big portfolio that we can offer, because we have antennas that fit in every position on the PCB board, no matter if it's in the corner, if it's in the center of the smaller side, or if it's in the center of the long side. For every solution we have something, and most people even choose multiple antennas on the board because of the different polarizations that they cover. So it's always recommended to have one antenna covering the vertical and one antenna covering the horizontal polarization to optimize the performance in general, and collecting data which are similarly polarized. All our products you can find, by the way, on the link on the presentation, which will be later shared. To make it a little bit more technical as well, this is some of the tests we have done for the two main channels, channel 5 and channel 9. So we measured the return loss, efficiency, and phase variation, and that's really where the tulip antenna, our LDS antenna, is the most advanced one, because we have the least phase variation, meaning that in a 3-dimensional space, this antenna can collect the signals in all the frequencies in the best way. Also for having such a broad bandwidth in each single channel of 500 megahertz, the phase variation in each channel can be already quite visible. So the higher frequencies, since they move faster, compared to the lower frequencies, arrive also faster on the device, and that's where the 3D design can optimize the signal strength and the overall efficiency. Also here, we already have done some tests with a small array of these LTS antennas. So that's also possible, and we do customized evaluation boards as well for higher quantities at least. Generally speaking, all of the antennas have a quite nice average efficiency. So it's really depending on the location you want to place your antenna, how you want to integrate the antenna, how much you want to spend on the antenna to choose the right ultra-wideband antenna in this case. So yeah, that's what's the first point in the small summary for ultra-wideband. So there's not a single universal antenna that might be used for a single device, but there might be multiple solutions or different solutions that work better in different use cases, depending what is the focus on in each application. Also here, the polarization has a big critical influence on the phase distribution, and always there should be multiple antennas to cover the vertical and horizontal polarized signals. Also, depending on the device's configuration or the way the device is used, the antenna differ a lot just based on their radiation pattern. So, for example, the smaller chip antenna has a rather optimized gain in the upper and lower z-axis, while our tulip antenna, the LDS one, is quite nice in the upper hemisphere, and this one is one of our FPC type antennas or PCB antennas. Is quite nice in another direction. In this case, it's the minus x axis, I would say. So also that really depends on how you want to use the antenna. If you just want to face forward, the tulip might be the best antenna. If you just want to cover a whole space, the chip antenna might be better. Or if you need specific directions, other types of antenna are better performing. So what we recommend, a few questions, our small checklist, what type of antenna is required. So it really depends on the technologies that must be integrated in the device. Usually for cellular or low power wide area networks and ultra wideband, there is no interference, so that's quite nice compared to, for example, cellular and Bluetooth, because the cellular range is quite close to 2.4 gigahertz. So that's another disadvantage using these two technologies together. Also, it should be clear which frequencies must be covered. So if you want to choose ISM 868 950 megahertz, or if you want to use NB-IoT or LTE-M, or if you want to choose channel 5 or channel 9 in ultra-wideband, for example. And the size of the PCB is quite important, as I said a couple of times already, especially for SMD and ground plane dependent antennas. The space on the board is important to know. So whether the antenna is placed in the center of the PCB or on the corner of the PCB, but usually we can offer some solutions for all of that. Also important to check what are the surroundings, is there any metal around, some batteries, some other influencing materials, and what's the end user's environment. And to get a little bit deeper on that topic, I have a few more slides just to show the influence of different effects on antennas. So here, the first slide of this part is focusing on the PCB size, and that's especially important for low power wide area networks or cellular NB-IoT LTM networks. So the size of the PCB really is extremely important. In this case, we cut down our standard eval board from 110 millimeters to 50 millimeters. So it's around a 55% difference in size and in performance in the efficiency in the sub-gigahertz range. In this case, it's optimized to around 1,000 megahertz or 1 gigahertz or below. And as you can see here, the influence is drastic, and the PCB size always is a big role, especially for these types of frequencies. For higher frequencies and also for ultra-wideband, this is not the case, and here it's actually rather the other way around. So the smaller board has better performance compared to the larger boards. So here, purple is the biggest board, and this kind of orange, pink colored lines are the smaller boards, and as you can see, they're quite well balanced as well on the upper frequencies. And also for ultra-wideband, they are similarly dependent due to the higher frequencies compared to Bluetooth, or to 2 gigahertz, to the upper frequency ranges here. So that's one of the biggest effects and biggest mistakes we see customers make. They have a super small PCB, which is not according to our design guidelines. Another effect we see is the antenna is placed in the wrong side, or wrong location on the PCB. So usually for the cellular or ISM antennas, we recommend in the top corner somewhere of the PCB, not in the center or not here on the sides of the PCB somewhere, or randomly in the middle of the board. So as you can see here, the top left position compared to the center position, the total coverage is extremely different. So here we usually cover some kilometers of range, couple of 10 kilometers of range, and here it's less than half, I would say, in overall. So that's also another big mistake a lot of customers make. This also counts, by the way, not only for cellular, but also for Bluetooth, for GNSS, ultra-wideband, and all other technologies. Also, the board size is different for the different antennas. I mentioned that in the beginning. So these two on the left and the two in the middle are our main LTE antennas, and also they have different PCB sizes, which we recommend are optimized for each antenna. The other effect I wanted to show is the body absorption and material detuning influence. So as you can see here, when you have a device that's worn close to a human body, or of course also animal bodies, the influence of human absorption is quite strong. So that's why we have special equipment in our chamber, like these heads or hands that we can measure exactly the influence on. In this case, it was a TRP measurements, active measurements, and the delta is around 9 dB between the free space and beside head and hand measurements. And the other influence, which is also often not considered, is the material detuning. And here, that's especially interesting for ISM 868 and 915 megahertz, because they are very narrow in the frequency bandwidth. So especially here, if you have the antenna detuned by just a few megahertz, the whole device will have much bigger losses than when it's optimized to the material where it's applied on. So here we tested glass in blue, plastic in green, and free space in red. And since this antenna is tuned to be mounted on a plastic housing, PC or ABS material. You can see the return losses are at minimum in exactly the frequency where it's wanted. In this case, 2.4 gigahertz, or the center of the 2.4 gigahertz band, so 2.44 gigahertz. And in the free space, it's much farther to the right, it's around 3 gigahertz, and the glass, it's much farther, 300 megahertz to the left, somewhere around 2.1 gigahertz. And as I said, especially for LTM, NB-IoT and the narrowband technologies, 868-950 megahertz, that is a huge influence factor. And since this is quite complicated, we have a big team of product managers and project managers located in Europe, where we can optimize customers' designs. I'm also located here in Europe, so I can also have the first reviews and have the first checkups on the board, on the environment, etc., to make sure that your device is working as best as possible in each application that is required, and to show a little bit about the process on how we are doing that. Typically, we start with the design phase, where we take a look at the customer's current design, the goals, where he needs to be in terms of performance, in terms of requirements, in terms of products. Do some recommendations, layout reviews, simulations, or if required, some custom antenna designs. Having then some prototypes, mock-ups, where we can do the first testings in our measurement chambers, or optimizing already some positions of the antennas. Then we are continuing with our test phase and optimization phase, where we do the measurements, tuning, active and passive testing, and we also offer FCC and CE pre-checks. So we measure not only the frequencies that are required, or each single band if it would pass the certification, but also we can measure some of the harmonics if they influence the device in a worse way. Also, then we do validation and factory samples for the pre-production, for example, finalizing the design with further documentation. This could be a custom data sheet, but also PPAP documentation or other documentation for different use cases. And in the end, mass production or delivering the product. So that's really to help you as a customer to find the best antenna. In terms of custom antennas, so everything shown so far has been our standard components, our standard parts that we have on the website available. On the website, you can also find a lot of different additional materials. And these are some of our examples for custom antenna designs, especially for challenging mechanics. So we have multiple technologies we can customize. One of them is LDS, which is some of the parts you can see on the right side here. So that's a plastic carrier which is metallized with a laser structure. But we also do, for example, PCB or flexible PCB antenna designs custom. We can also do stand metal antennas custom. We have multiple 3D printers in our facility to do some custom housings to test as well, just to see some mechanical fits. And of course also injection molding, insertion molding, etc. And this is done in our multiple facilities. Mostly we do custom in Vietnam, actually. Also here you have additional information online, but you're also always very welcome to ask some questions directly to me or to the guys at Rutronik in case of questions. Some more impressions of our design center. So this is the one in France where we have our automotive test chamber, which we developed our own by ourselves. We do not only make automotive measurements there, but also everything that doesn't fit in the regular measurement chamber. So, for example, a fridge or some HVAC devices or other bigger devices that do not fit regularly. We can also do active and passive measurements here. Then we have multiple other chambers where we can do also specialty testing, for example, angle of arrival for ultra-wideband and Bluetooth, phase center measurements for GNSS receivers, or we have our own millimeter wave test chamber, which is the one on the top right. And here you can see, for example, some measurements for ultra-wideband where we are quite close in the centimeter range or sub 10 centimeter range in terms of our precision with our optimized antennas. And as I said here, also some pictures from the FCC CE pre-checks to see if the device would pass. We also do measurements with just the PCB board, but also with housing, because also, as I said, the housing makes a big difference. And we have one custom device in our facility where actually the device would pass certification without housing, but with housing, the influence is worse, that it would actually fail the certification with housing. We also have some other measurements for MIMO systems. So also here, if you have multiple ultra-wideband antennas on board to cover vertical and horizontal polarization, we can do MIMO measurements here, and then you will get something like this, which is a combined chart of both antennas in the same device. And this is an example where a customer actually failed the certification due to the harmonics. So that's why we are there to cover you and make sure that your device will not do the same, and you can always make sure to pass the certification if needed. Of course, this is not always for free, so we have a custom part number list on our website where you can actually just order certain services. So you can just go through the website and have a look there. And for example, you can choose different measurements for each single band. For LTE, you can have different measurements for ultra-wideband. And based on that, we can create the offer. For higher volume quantities, we often do some parts for free. Just to show some applications, in this case, it's old design, so it's not including ultra-wideband, but typically these are exactly the applications that would include ultra-wideband, so some trackers for fleet management, for animals, as I have shown in my use case here in the presentation, and some rugged battery-powered GPS tracker as well. Today, as you might know, in some of the smartphones, there's already ultra-wideband included, so you have some tags usually that you can track with ultra-wideband or GPS additionally, and have some cellular connection there. So these are really the main use cases we see. And here are some custom antenna trackers. So here we are using our LDS technology to combine multiple antennas in one plastic carrier. In this case, it's NB-IoT and GPS, and here we have actually much more antennas in one plastic housing, which is also the main benefit of having an LDS device, but the quantities should be quite high, around 100K pieces typically. And on the top, you can see some pigeon tracker, also some animal tracking here, using GPS mainly, which will be read afterwards. And in this case, we are using some FPC antennas, which are folded here or bent in here in this kind of plastic carrier. So, as I said, most of the parts and most of the information you can find online. We have a quite nice online tool to look for the standard components, but we also have always next to our data sheets, we have some application notes, Gerber files, 3D files, simulation files that you can directly integrate into your development. We also have some reference guides with the main chip and module suppliers for different technologies. So it's recommendations. For some of them, we are already reference suppliers for certification. So that's worth taking a look at. And of course, we have some sample boxes and sample kits. I would always recommend to have the personal contact because we can give them out for free. But there's also an option to order these at Rutronik. In terms of technical resources, we also have quite a lot of white papers, case studies, and one-pagers, flyers, etc. For example, our tracker flyer that you can find online, just to have a nice overview of all different technologies we have. And we are working together with an IoT optimizer where you can upload your application and predefine some values, some modules, antennas, etc., also batteries, to see what it will look like in the end in terms of battery lifetime, in terms of data packages, in terms of indoor-outdoor usage. What's the difference between that? So you can really optimize the device and pick the perfect antenna based on a big database from Telecom. Just to summarize a little bit on our benefits, besides having a huge portfolio for standard products and our knowledge, we do custom solution for challenging mechanics. And according to my experience, that's the most interesting ones. And especially innovative products, they usually have challenging environments they work with. So you're always welcome to reach out to us or Rutronik, and we can find the best way to find the best antenna solution. And then once that's designed in, we do offer validation and pre-certification. And you can always find our products together with our partners on the website or on our partners' websites. That's it from my side. Thank you a lot for the attention, and thank you as well, Tobias and the team from Rutronik, for having us here in this nice webinar series.
Thank you very much, Jens, for your presentation. I would like to jump straight to the Q&A session. We have some questions. The first one is, are there differences in the antenna technology types in terms of performance? So chip versus metal stamp versus LDS?
Yes, of course there are. So as I said, also a little bit in the presentation where I slightly mentioned it there, the metal stamped antennas are usually the most noise, how can you say, noise reducing antennas. So, or the antennas which are not affected by noise as much as other technologies like chip antennas, for example. They also make a big difference in terms of where to place the antennas. And of course, the radiation pattern, the polarization is different in each type of antenna, but also in the placement. And that's why we developed the LDS antenna, to have one antenna that has the broadest usage for most ultra-wideband applications. So that's the main differences. So the polarization, the positioning, the whole assembly, and the affection of noise by each antenna type.
Thank you. The last question I see is there a PCB size influence for ultra-wideband?
There is. So the PCB should usually not be too big. as we have seen on the one slide with the cellular part, the sub-gigahertz is influenced a lot by the size of the PCB, and the upper frequency ranges, in this case it was 2 gigahertz, was also affected, but in another way, where the bigger PCB size actually had worse performance compared to the smaller sizes. So there's always this preference. What should be preferred? Is it the sub-gigahertz on the PCB or the ultra-wideband tracking, for example, on the PCB? So there usually needs to be some kind of compromise to optimize for one of those technologies, depending on what's the most important one.
Okay, thanks, Jens. These are all questions for now. Of course, if you have any questions, you can contact us afterwards, and we would like to give you the answer, of course. Just a few words from my side at the end. I will share my screen. So I think you can see my presentation. If you want more information, you can have a look on our Rutronik webpage, also on our webshop Rutronik24 and on Rutronik Tech. Also, please follow us on social media. We are on LinkedIn, Facebook, Instagram, and YouTube. If you have any questions or want any information, you can contact me directly. You can see my contact information on the left side, or you can, of course, contact your regional Rutronik manager. Also, you can ask your question on the contact form you can see on our webpage and on the right side here. Don't miss our next webinars. Here we had KYOCERA AVX. Tomorrow at 10 a.m. we have Edge Pulse with firmware development for Nordic Edge ML devices. And tomorrow in the afternoon we have Yakeo Pulse with innovative antenna solutions for wireless communication. Experts discuss LoRa and ultra-wideband technologies. Also, don't miss the opportunity to join our next webinar series with Bluetooth that starts on Monday, the 4th of November until Friday, the 8th of November. Here we have our suppliers Panasonic, Minu, Nordic Semiconductor, Inside Zip, Infineon, and of course, again, KYOCERA AVX, as Jens already told us. So at the end, just thank you very much, Jens, for the great presentation. Thank you, everyone, for your participation, and I wish you a nice day.
Yep, thank you, guys, and have a nice week.
Bye.